Hello guys, how are you? So today we are going to see one of the most important topics. So many of you just know how vector stores are created and all those, but in reality you don't know actually how those vector embeddings are stored to the specific vector stores and which types of methods are utilized there. So if you know like what is the meaning of that HNSW or K exhaustive nearest neighbor or approximate nearest neighbor search and all those things, then those things you should must know because you know just creating chunks and passing those chunks to the text and doing all those things like just passing those embeddings to the vector stores doesn't mean that you will know everything. Actually, you should know like the way they have given here representations, how like vector search or hierarchical navigable small word search, how it works, how embeddings are stored to the in those vector stores, and whenever any specific user query is coming, then how those users based upon that user's queries, how documents are searched. So, there are various vector stores like ChromaDB is there, Azure AI Search is there, then there is Deep Lake is there, Pinecone is there, and so many of them are there. But you must know like which one of them is utilizing what types of methods for the uh, indexing of those vectors. So one is like hierarchical navigable small words, so you should also know the like what are its pros and cons, because you know what happens in hierarchical navigable small word search. Actually, whenever we are doing indexing of all those vector stores, like maybe 1000 chunks or 10,000 for 1 lakh chunks, whatever. So whenever user is asking the query, that time what happens for that each user queries, all those vectors are loaded into the memory. So it's required a huge memory, and also it's not good for to give this precise context because it's that hierarchical navigable small world will focus on that recall of that query's similarity. So instead of giving exact matching, it will try to search all the vector store database, and within that it will try to give the most relevant documents. But if you apply for that exhaustive k nearest neighbor, then it will just take based upon user queries. Instead of loading all those vector stores embeddings, it will just based upon user, it will try to search the best exact nearest the matches, and it will just give you only those. So there is precision is high for that exhaustive k nearest neighbors, but recall is very low because it will not going to search the entire vector store. So sometimes results may be not added there or those will be not given. So actually you should know also here is they have given in Pinecone article of that they have mentioned very well how that hierarchical navigable small world is working, how those distances are calculated, and how it's going through the graphs and all those things. So it's based upon a graph like edges, vertex, nodes, and all those things. So they have mentioned here also each vertex and graph connects several other vertices. We call this connector vertex friends, and each vertex keeps friendly creating our graph. So there are also different types like low degree vertex and high degree vertex. And actually, what happens while creating that hierarchical navigable small world? So you are defining the graph like as shown here in this plane. So there will be a layer by layer hierarchical structure. So the topmost layer will have the highest or max vector context length, and they are also representing the more meaning of those vectors. And as you go below to that graph, then there are they have given the vectors, but those vectors will have the trimmed or cropped versions, and they will not giving all those meanings. So what happens actually exactly in the hierarchical small words when user is asking the query? So based upon query, initially it's will goes to the top layer, and it will try to find that node or edges where that query is matching or trying to capturing the meaning. And if any particular top vectors is not giving the right one, then it will go to the below one's vectors or layers, and from that it will try to get the more and more results. So this is very in general construction means what I'm saying, but you need to do in a very theoretical way. And also like the pros and cons for that hierarchical navigable and KNN neighbor search, because without that it's very difficult to understand. And already Google has given one AI mode here, so you can do all those things. So you can see like speed and scalability. So HNSW provides signal faster search times compared to brute force KNNs, especially for large data sets and hidden data, achieving near logarithmic query complexity. As I have mentioned, like HNSW generally offers high recalls, meaning it's find the approximation of the true nearest neighbors. It supports very dimensional distances, but cons is also there. Like as I have mentioned, it's entering loading all those data, so it can have a memory requirements. Then in just construction overhead, like building each other in these for very large can be computational expensive and time consuming due to hierarchical structures and creation of this parameter tunings. Other performance often requires years like parameter number of neighbors in each layers and search scope during index, all those things. So I hope you should know exactly how these are working and when to utilize which one. So try to utilize like these. So HNSW is faster, scalable, high recall, then it has KNN brute force. So KNN guarantees finding the true nearest neighbor by comparing query having every data points and data simplicity. Performance decrease with so KNN has issue like it's really degrades performance when the data is very huge and high dimensional, slow search times, inefficiency, high dimension, and all those. So I hope friends you must know, because nowadays interviews are asking these types of questions, and you should give all those answers very well. Just grading chunks and grading embeddings does not solve your problem. So you have need to do all those things very well. If you have any doubt or issue, try to ask me in the comment. I'm always there for to help you. Please let me know how videos are going on, and have a good day. Bye bye.